Mm-hmm. Mm-hmm. Let's do it. Let's go over some stoichiometry practice problems from the sheet. Finally. I've been threatening you with this for like days, weeks, months, and we're ready. All right, so let's go ahead and take a look at this first problem. The second problem down here, the one that starts with, it says nitrogen gas is reacted. When it comes to gas stoichiometry, and there is a gas stoichiometry second part of this problem here, talking about gases at STP, figure out liters, we have to use the ideal gas law. We haven't done gas laws yet, so I'm not going to do that problem, but you want to hold on to that. And actually, you could do 2A and 2B. So you can go ahead and do those, and I'll give you the answers to those, but you won't be able to do 2C yet. So I will not go through this in the video, but the first two you could do on your own. Let's go through these in the video. And actually, that's going to be enough stoichiometry. You're going to be sick of it. You're not going to be going, I don't want to do this anymore, man. I get it, okay? I get it. And if you don't get it, you just keep rewinding until you get it or ask me questions in one of our Zoom sessions. So let's go through, do the first three on this list, which are problem one, and get her done. All right? So this is a little bit more chemistry than the last problems that I made up. I made up problems which were simple equations, and I had them already there for you. We don't have that. In fact, the first question is write and balance the chemical reaction. So we've got to write the reaction for this. Well, let's do it. Silver nitrate. And they give me the words. I got to put the symbols in. We got a formula right. So silver nitrate. Silver nitrate. Those are the words, the symbols for those words. You know nitrate, NO3. Reacts with, that means plus, reacts with barium chloride. Okay. So all I'm doing is putting the symbols in for the words at this point. That might not be written right. We'll go back and check it. Okay, to form, arrow means to produce, silver chloride and barium nitrate. Okay, so I put the symbols in for the words. Now let's see if those compounds are written correctly, because they might not be. Check the charges. Silver is a +1, nitrate's a -1. That's good. Barium's a +2, chlorine's a -1. That's not good. So bring that 2 down for a subscript because they don't cancel each other out. Remember, crisscross. Silver's +1, chlorine's -1. Good. Barium's +2, nitrate's -1. Not good. Bring that 2 down for the nitrate outside the parentheses. So there we go. A little review on writing formulas. Now we got to balance it. We'll see if it's balanced. Remember, my guidelines are balanced metals first. Silver, balanced. Barium, balanced. Those are my metals. I like balancing polyatomic ion groups next. So polyatomic ion group, nitrate, there's one of them here, but there are 2 of them here. We need a coefficient out here in front of this to make that 2 nitrates. Now what that does, some of you astute people have said, well, that'll unbalance your silver. Correct, we're going to have to fix that. I like fixing things right away. Some might want to wait and keep going with other things, but I like fixing things right away. So 2 silvers, I'll fix this silver with putting a 2 there. All right, next, I would check the chlorine. That's my last thing, and I would check that next. Last thing to check. 2 chlorines, now I have 2 chlorines. So by fixing the silver, I got the chlorine balanced. So that's a nice balanced reaction, and that's actually part A. We did that, right, and balanced the reaction. Good to go. Okay, stoichiometry. B. If 410.8 grams of barium nitrate, so 410.8 grams of this barium nitrate are made, how many grams of silver nitrate were reacted? Or I'll put question mark grams here, that's what we're trying to find. How many grams of that silver nitrate were needed to produce that 410 grams of the barium nitrate? Now, you don't always, most of the time you're trying to figure out product, but not always. There's a problem where we have stoichiometry. We're going to figure out how much stuff must have reacted. That's okay, it doesn't change anything. It doesn't matter who you're looking for. Stoichiometry is dimensional analysis, and it's done all the same. So what do? Well, you know grams to grams, right? After the last couple of videos, you know this is going to be a 3-stepper. 1, 2, 3, stepper. Now you know that. So now what we're going to do is write what we know first. This is going to take a lot of room. So I'm going to write that over here. 410.8 grams of barium nitrate. Multiply, divide. Okay. Grams of barium nitrate goes on the bottom. Maybe that's a gram ratio. Gram to gram ratio. No, no such thing as a gram to gram ratio. Mole ratio, yes. Gram ratio, no. So what do you have to go to if you have grams? You have to go to moles. It's your only choice. Remember, Chicago. So you have to go to moles. So moles of the barium nitrate goes on top. One goes next to the mole here. That's because up here there's a 1 in front of the barium nitrate. No, no. When you mole to grams, always a 1. 1. I have to add all this stuff up. Now this is one where doing it in my head might be a little bit of an issue. So I'm going to I might make a mistake. So I'm going to go ahead and write this one out. Barium, I have one of them. Barium has a mass of 137. So I multiply those. Okay. Nitrogen, I have 2 of them. That 2 multiplies that nitrogen. So 2 times 14, 28. 2 times 14 is not 14. 28. And then oxygen, we have 6 of them. So 6 oxygens times 16, that's 96. Do the math on that, that's 1521, 27, 96, 26, 16, and then 1, 2, 261. But I'll always check myself. I always like to check myself. Okay, I like hockey. It's coming back. It's coming back. Yes, it is. Okay, so I'll do it in different orders. So that's 14, 21, 2, 11, 12, 13, 14, 16, 1 second. Yep, we're right, 261. 261 goes in here. Okay. I'll leave this up for a minute in case you were looking at it. Then, another step. We're not done yet. That's only one step. All of that just for one step. Step 2. Boom. Moles of barium nitrate on the bottom. Moles, barium nitrate on the bottom. Bells and or whistles are going off. You know it. The first time moles appears on the bottom, you have your mole ratio. And you have to have a mole ratio in every stoichiometry problem. Yes, this is it, our mole ratio. Which means I go from moles to, it's a mole ratio. Moles of anything I want. This is what I call the gear changer. We can shift from one compound to some other compound, any one we want, in the equation. We want to get silver nitrate. So I'm putting moles of silver nitrate on top. So moles of the silver nitrate goes on top. Okay. From the balanced reaction coefficients. So moles of silver nitrate, I need 2. 2. Moles of barium nitrate, I need 1. Okay, so those numbers come from the balanced coefficients, balanced reaction. I'm not done yet, because this gives me moles of silver nitrate, but what did I need? Grams of silver nitrate. So one more step, and we'll be good to go. So moles of silver nitrate goes on the bottom. Bells and whistles, right? No, no, no bells and whistles. Why not? It's moles on the bottom. For several reasons. One, you get 1 mole ratio. That's it per stoichiometry problem, and we've used it. 2, the mole ratio is when the moles on the bottom happens first time, not second time. So this is not going to be a mole to mole, it's going to be a mole to gram conversion. So if you've already used your mole ratio, you're going to have moles to grams. So grams on the top. Okay, moles to grams, we put a 1 next to the mole. We're going to have to add up silver nitrate. Let's see if we can do this in my head. So silver, it rounds up to 108 plus 14. That's 122 plus 3 oxygen, 16, 16, 32, 48, 120, what did I say, 122, 122, 130, 170. 170. Should be 170. Well, let's verify that. Let's do it backwards. I'll do it backwards. That's 48 plus 14, 58, 59, 60. 61, 62 plus 108 would be 170. Yep, so that works. Okay, so now that cancels. And do the math and get an answer for that. And let's see what we come out with. Everything on top gets multiplied. Everything on the bottom gets divided into. All right, so here we go. Here we go. 410.8. 410.8 times 1 doesn't do anything. Divide by 261. Divide by 261. enter. I always hit the enter, don't screw it up. Times 2, enter, times 170. Enter, and we get our answer. With 4 significant figures, it's 535.1. 535.1. Okay, 535.1, and it's grams of the silver nitrate. All right, that problem is done. That's problem B. Problem B. B is in Brontosaurus burger. That's what Fred Flintstone liked to eat, Brontosaurus burgers. Okay, let's do part C. Part C is interesting because it's a little bit different. I've been talking about grams to moles, moles to grams, moles to moles, grams to grams. This one wants me to go from, if we read this, grams to formula units. Remember formula units from last week when we were doing mole to grams, moles to molecules, formula units? Yeah, watch me do, how am I gonna do that, right? Okay, well, don't panic, no panicking. No, don't panic. So what I'm gonna do this time is I'm given grams of the barium chloride, how many? 39.02. So 39.02 grams of this. And it talks about being reacted in excess of silver nitrate. So we'll talk about that actually in the next video. Next video we go into limiting in excess products and reactants. So hang on with that one. How many formula units of silver chloride of this silver chloride? How many? Don't take that personally, please. Thank you. It's an abbreviation. Don't. Sorry. So how many formula units of that would be made? Well, interesting stoichiometry problem. Let's dive in. It's all dimensional analysis. So write down what you're given. 39.02 grams. 39.02 grams of the barium chloride. Yes. Okay. Grams of barium chloride on the bottom. Okay. So grams got to go to moles. Got to go to moles. So moles of the barium chloride on the top one goes next to the mole. We got to have the barium and chlorine. Barium was 137. Chlorine is 35 and 35. Actually, it's 35.45. So actually, if I have 2 of them, I usually just with one of them, I run at 35. But with 2 of them, I would go 35.45 to 35.45. So I go 71 on that one. Okay, I'm going 71 for 2 chlorines. 71 plus 137. So that's going to be, well, 130 plus 70 would be 200. So 71 and 208, right? 208. That should be 208. Right, that's 137 plus 71. Just checking. 8, 0. Yeah, 208. All right, always check. Okay, so grams gone, moles. Moles goes on the bottom. Yes. Yes. That is your mole ratio. So I'm going to put moles of whatever I'm trying to find on the top, and I'm trying to find formula units of silver chloride, but I can't get there until you go through the mole ratio. So I have to put moles of the silver chloride first, and then we'll take care of the formula units. So moles of the silver chloride goes on top. Balanced equation. I get my numbers in here, the coefficients. It's a 1. Okay, moles of the barium chloride now cancel, leaving me with moles of silver chloride. Now you might say, oh man, how are we going to get from moles of silver chloride to formula units? Remember the last unit, we went Boston, Chicago, San Diego. Formula units are living in San Diego. And right now, what city are we in? Come on, you say it. You can say it. You know, I know you know it. And you know I know. Chicago. So we have one more step to go from moles to formula units. All right, we've done this, moles to formula units. I mean, you might have it might not be something you saw right away, but I hope now you see it. We can go from moles, and then silver chloride. Oh, that's a mole ratio, right? No, remember, no. Only the first time moles is in the bottom, it's a mole ratio. This is not a mole ratio. We're going to go from moles to something. And now if you're in Chicago, a lot of times we go from moles to grams. That is very common. The most common thing you're going to do is go from Chicago to Boston, moles to grams. This time, though, we're going from Chicago to San Diego, formula units. So, Fu, doesn't sound good. Silver chloride. What's the numbers in? One goes next to the mole. Remember, when you're in San Diego, always use Avogadro's number. Yes, 6.02 times 10 to the 23rd. All right, this is now set up to solve for the formula units of silver chloride. Let's do the math. All right, clear. 39.02, 39.02 times 1 doesn't do anything, divided by 208, enter, times 2, enter, times 6.02, second function, exponent 23, boom. 4 significant digits, it will be 2.259. 2.259 times 10 to the 23rd. So 2.259 times 10 to the 23rd. And there we did another stoichiometry. This one with a little different ending, but hey, we just pulled something back from the past in, and we can do that. So that's plenty of formula units. There's plenty of stoichiometry now that we have done in these videos. And in fact, we now go into the next application of stoichiometry, and that is what's called in excess and limiting reactants. So, and that uses stoichiometry, so there'll be more practice there. Okay, so for now, direct stoichiometry, done.